So up until this point, we've been working with systems of equations that have two variables. Today, we're introduced to systems of equations that have three variables. Now, we're not going to have to solve these algebraically. Thank goodness. We can do it, but we're not going to. Instead, I'm going to introduce something called a matrix to you. Now, a matrix is something that we can create that in the end we can put in the calculator and it will solve these systems for us. So that's why I was saying you're going to love matrices, because the calculator does most of the work. All you have to do is create the matrix. And then, yes, you'll have to type in numbers to the calculator. So here we have our first system of three equations. Now you can use a matrix on any system. You could use it when it has one variable. You can use it when it has two variables. You can use it when it has 100 variables. We will not be doing 100 variables. The most we'll be doing is 3. Now, as far as setup goes, looking at your system, you need to have all of your variables lined up in the same columns. So lucky enough for us, everything is lined up like it should be on this first example. We have x plus 3y minus 3z equals 12, and then we have 3x minus y plus 4z equals 0, and negative x plus 2y minus z equals 1. So the x's are in the first column, the y's are in the second, and the z's are in the third. And the constants are on the other side of the equal sign. So now what I want you to do to create our very first matrix, which is exciting, go ahead and create a square bracket that is 3 stories tall, or 3 rows tall. The same height as the 3 equations in our system. Now what you're going to do is inside of your matrix, you are going to take the coefficients on the variables. Now, what is a coefficient? What is a coefficient? Very good. The number in front of the variable. So, on the x in our very first equation, what is our coefficient? An invisible 1. So inside of my matrix, I'm going to take the 1 and place it in my very first position. Then, what's the coefficient on the y? 3. So I place a 3 in the same row as the 1. And then what's the coefficient on the z? Negative 3. So I'm going to place a negative 3 next to the 3 that was for the y. And I've created my first row in my matrix. So that's how wide my matrix needs to be. I can close the bracket. Now I repeat this process for the other equations. What is the coefficient on the x? 3. So I place a 3 below the 1 that was for my other equation. What's the coefficient on the y? Negative 1. So I place that in my second row, second column. And what's the coefficient on the z? 4. So I place that in my second row, third column. Now to our last equation, what's the coefficient on the x? Negative 1. That goes in my third row, first column. What's the coefficient on the y? 2. That goes in my third row, second column. And what's the coefficient on the z? Negative 1. So all I did basically was keep everything in the same position. I just got rid of all the variables. That's all I did. Got rid of all the variables and just left the coefficients. Now, we do need to create a second matrix for the constants. This first matrix is what I like to call our coefficient matrix. It's where all our coefficients go. The second matrix goes right next to it. And this is where we place our constants in the exact same order as we see them here. So I'm going to place a 12 in the first row, first column, a 0 in the second row, first column, and a 1 in the third row, first column. This is what I like to call our constant matrix. Now, technically, these two matrices should be set equal to each other, but that's not how we would put it in the calculator. So what you do instead is you take your first coefficient matrix and you inverse it. Does anyone know how we can inverse something? What's the symbol for inversing something? You may not know, so I may just tell you. Inverse is raising something to the -1 power. So I'm raising that first matrix to the power of -1. Okay, I have everything set up. Everything is how it should be. Now, all I have to do is type all of this in my calculator. So now is when we pull out our calculators. In order to get a matrix on your calculator, what you do is you hit, so I should say, in calc, you hit alpha, zoom. Alpha, zoom. And there should be a little window that pops up asking you how many rows and how many columns are in your matrix. So in our first matrix, how many rows did we have? 3. And how many columns did we have? Also 3. This is called a 3 by 3 matrix, where the number of rows is listed before the number of columns. So in my calculator, where it says row, it should be highlighted over 3, and you press enter. For number of COL, which stands for columns, again, you should highlight over 3 and press enter. And then you just arrow down and hit enter on OK. So now you should see a matrix that has all zeros as your values. What you should be doing now is entering all of the numbers that we found in our coefficient matrix. So 1, 3, -3. Then in the second row, 3, -1, 4. And in the third row, -1, 2, -1. I'll give you a minute to do that. All right, guys, now this matrix, we entered it wonderfully, I hope, but remember, the matrix needs a what on it? -1 as the exponent. Do you know how to get a -1 as an exponent? What do you hit? Yes, there's literally a button underneath math for inverse. X to the -1. You hit that button, and that's how you inverse the matrix. So now, we're going to have to create a second matrix for our constant matrix. So again, we hit alpha, zoom. But this is not a 3 by 3 matrix anymore. How big is this matrix? How many rows? It has 3 rows and how many columns? 1. So it's a 3 by 1 matrix. And we type in 12, 0, 1. And then you just hit enter. Now, can anyone take a stab at what these values mean? Because the very first column was our x values, that means that the very first number is what x is equal to. Because our second column was our y's, the second number is what y is equal to. And because our third column was z, the third number is what z is equal to. So I'm going to write as my solution, I need to write this out, x equals 3, y equals 1, and z equals -2. And I circle it and I'm done. My calculator did all of the hard work for me. I want you guys to try to work on the matrices on the back, on the practice. Those 3 matrices I want you to write. You actually need to write the matrix if you want full credit on your test or quiz. But you are going to use matrices to solve these 3 practice problems.